Okay, this is page 26 of the Unit 6 notes, and this is just a little intro to the chain rule backwards. So we're going to get to the chain rule backwards in just, we're going to get to it next class, but for today, we're just doing an intro, and we'll have a few homework problems that are based on this that are, kind of like this. So how do we do the chain rule backwards? So the key to figuring this out is to figure out what does it look like forwards and look at that and then unpack it. So I gave an example. So here's forwards. The question is, what's the derivative of that thing? And, we know how to do the chain rule. It's going to be take the derivative of the outside and leave the inside alone, and then times the derivative of the inside, right? So backwards, what we need to do is, if we get a problem that says the integral of cosine of x squared times 2x dx, so if we get this answer for a problem, we need to somehow be able to figure out that this is just sine of x squared plus c. Like, remember, taking the derivative and integrating and anti-differentiating, these just reverse operations. And so if the derivative of this gives you this as an answer, the antiderivative of this gives you this as an answer, gives you the first part as an answer, plus c at the end. So here's the observation. So let's look at that second one and see what happens when we do the antiderivative of this thing. One thing that's interesting is that there actually is a product here. And I said we don't do product rule. We don't really do reverse product rule because this came out of the chain rule. Like, there's a product in the answer here, but it wasn't because we did product rule when we took the derivative. It's because we did chain rule. So don't worry about, we won't actually undo product rule. Okay, so let's see what happens. So the derivative of the inside was just there at the beginning, was there in the beginning of the problem. Like, I've got an inside function, I've got an outside, I'm sorry. I've got an inside, and then here I've got the derivative of the inside. That's not great notation, but just to give you the idea of what these pieces are. So the derivative of the inside was already sitting in the integral. So the derivative of the inside was there already. When we integrate, so when I go from this to this, notice that the 2x vanishes. It's just gone. So this part disappears. Weird. So we needed the derivative of the inside to be sitting there. And then when we integrate, that part just vanishes. That's why we don't have to actually do product rule. Once we've taken care of that, then we just do the diff. My eraser's not working these days, so I have to do that one. We do the antideriv of the outside and leave the inside alone. So we do the antiderivative of cosine, that's sine, and then x squared we just left alone. So that might be kind of weird that the 2x just vanishes when you do the integral of it. But if you think about it, when we did chain rule, have been doing chain rule for so long. Whoop, it's lunchtime. We've done chain rule for so long, we're used to it. But when you do the derivative of a composite function, then you suddenly get this extra new function that gets created when you do that chain rule. Like, it started with one function with an inside. Now we've got that, new version of that with the derivative. And now we've got another function there. So something kind of gets spontaneously created when you do the derivative with chain rule. So when we're doing the antiderivative with a chain rule situation, then something is going to sort of spontaneously disappear. So I hope that gives you some justification for why part of it just vanishes. And if you have any doubts, just say, okay, I know I've done the antiderivative right. If I take the derivative of my answer, and that gets me what I started with, other than the dx, and if you take the derivative of this, I think you'll convince yourself very quickly that this would be the derivative. Let's show you a couple more examples of this. And on these problems that you're going to see today, they always are going to have these components. They're always going to have the derivative, the outside, the inside, and the derivative of the inside sitting there. Okay, so every single time it's going to be like that. So what do we have? I've got sine pi x and I've got pi. So I've got an outside, I've got an inside. I know there's no parentheses, but it's kind of implied that it's sine of pi x. And I've got the derivative of the inside. So what do? I make sure the derivative of the inside is already there. So in my 1, 2, 3 from up above, 1, check. The derivative of the inside is already there. And then kind of 2 is that when I do the antiderivative here, then the pi is just going to disappear. It's going to be gone. So all I have to do once I've taken care of 1 and 2 is I just have to make sure that I do the antiderivative of the outside, leave the inside alone, and then plus c. Check my answer. Do the derivative of this. Derivative of negative cosine is positive sine. Leave the inside alone. There's the pi x. Times the derivative of the inside, because of chain rule. That's where the pi came from. Done. And you might be like, well, what if it's not perfectly set up, Mr. Ellinger? For tonight, everything will be perfectly set up, so you don't have to worry about that. Every single time, there's going to be an outside, which is the square root, and inside, which is the 25 minus x squared, and then the derivative of the inside just sitting there. That's why it's intro day. We'll find out how we deal with it when it doesn't work, or when it's not quite right, next class. So you can try this one if you want to. You can pause me. I'll give you a second. Antiderivative of the outside. So it's 25 minus, and leave the inside alone. So the outside is square root. That's to the 1/2. So I have to do the antiderivative of something to the 1/2. So I bump the exponent, divide by the exponent, and the derivative of the inside just disappears. And I'm done. So make sure the derivative of the inside is there. It's just going to go away. Antiderivative of the outside, leave the inside alone. Check your answer when you're first doing this by taking the derivative of this. The 3/2 multiplies down, cancel out the 2/3. 25 minus x squared becomes to the 1/2, check. And then times the derivative of what's inside, that would have got me the negative 2x. Last example. Again, we've got, e to the something is the outside. Remember, this is kind of weird. With e to the something, it doesn't look like outside and inside functions as clearly as like sine or square root or, something to a power or natural log of something, So it's, I was trying to read my own handwriting. Sorry, it's surface pen. E to the something is my outside function. This is my inside function. The derivative of the inside is already there. So my answer, derivative of the inside already there, check. So that derivative of the inside is just going to disappear, and all I have to do is the antiderivative of the outside, leaving the inside alone. The antiderivative of e to the something is e to the something plus c. Again, if this negative sine x wasn't there, it wouldn't work because the derivative of this would make a negative sign, and if it wasn't there, then the derivative of this wouldn't be this, and I'd have a problem. But the derivative of this is this. Thank you for being there, negative sine x, and so that's my answer. Let me just show you one more, last one that I didn't include before, but I'm just going to include it here. It's going to be, this is a little bit harder, but not a lot. So it's 1 over x squared plus 1 times 2x dx. Right. So this is a little tricky here because it's like, wait, what's the inside function? If you want to, you could think of this as x squared plus 1 to the negative 1, and then it definitely looks like an inside function, right? And then it's like, oh, okay, now I see it. So the derivative of the inside, already there. So do the antiderivative of the outside and leave the inside alone and just get rid of this because it just disappears. So what's the antiderivative of something to the negative 1? Or the other way you can think of it is 1 over something. That's natural log. Oh, it's the one exception. It's natural log of x squared plus 1. Don't need brackets because x squared plus 1 is positive, so the absolute value wouldn't do anything. So parentheses are fine. If you did a absolute value, there's nothing wrong about that. It's just not needed. So, and then plus c. I wasn't going to forget. So again, antiderivative of the outside, and the antiderivative of 1 over something is natural log of something. But I needed that 2x to be there. So I'm going to give you a few problems that are going to be kind of like this. I think I'm just going to distribute it into OneNote so that you can do it there. And then I'm going to give you just a few AP Classroom accumulation problems. Just a few, not too much because you watch the videos too. Next class, we're going to go deeper into this chain rule backwards thing, and we're going to learn that integration by substitution that some of you have heard about, maybe from students taking BC or someone who took this class last year. But for tonight, all the problems will be set up like this, where you've got an outside, an inside, and a derivative of the inside. Okay? Cheers, and we'll see you next class. Stop it.